So now that we have to, now we're done with the MLFQ, the lost queuing system that I'm going to talk about for the single server case, for the single CPU case, is the real-time scheduler. The real-time scheduler is used for softwares in airplanes, flight path, for example. It controls the anti-lock brake skid system on your car, movies on your computer, and if you're playing Half-Life, when you fire a shot, you do not want it to hit your target after like 2 seconds. You want it to be very fast. So real-time scheduling is an approach to scheduling where you are actually giving some very high priority, basically uninterruptible. You basically have uninterruptible operations in your system that, well, does not yield to anyone, that doesn't even know what a queue is, or they just run. These are the highest priority uh, jobs are in your system. We'll talk a bit more about this when we also talk about priority inversion, which happens in actually multi-core processors. We'll talk a bit more about real-time scheduling. Now, I'm just going to hint about problems with multi-processor scheduling rather than solutions, so that when we talk about them later, you sort of have a hint of why multiprocessor scheduling, why everything that we said before does not really apply to multiprocessor scheduling. So let me ask you the first question: should we use a centralized MFQ with locking? Basically, you have a centralized MLFQ with a lock whenever whenever a CPU, now you have multiple cores, so you have 4 cores, and we I was asked that during the discussion session last time. So now you have 4 cores, and all cores are basically operating on the same queue that you have, on the same queue, MLFQ that you have. So you have a single MLFQ that for all the 4 processors. And when you're acting, because in that case, the scheduler basically needs to decide on a per core basis what will happen based on this central MLFQ, and it will require some locking on the MLFQ, because you will want to lock, if something got scheduled already, you would want to have some locking mechanism, basically. Not so it's if it's scheduled right now, you want it to be accounted for in such a way that if doesn't get scheduled on other cores or anything, so you would need a lock on the queues. This has an obvious problem, is that now you have 4 different processors competing for that lock to actually get their new schedule. There are cache slowdowns because right now a process will not run on the same core always, because right now there are 4 cores, central queue, and that queue can basically run the same process whenever it's time for that process to run. It can run it basically on the first core, second core, the third core, or the fourth core, depending on which core becomes empty and which process has its turn now. So the problem with that is that in modern computer architectures, with each CPU core, with each CPU, there is a cache that is sorry, that there is an adjacent cache, and that adjacent cache is basically for this core only. It's not for the whole CPU. There is a common cache, but there is a cache per CPU there. So that means that since you're jumping between the different caches, you're jumping between the different CPUs, so you're jumping literally between the different caches. If you get scheduled on a different core, the next time you get scheduled as a process, you will have a cache miss, which basically means that you will, right when you get scheduled, you'll get basically kicked out because of IO. Now you need to go and fetch the data from memory. So that is an issue. And then there's limited cache reuse. I mean, you have already fetched this data, so you want to use it once it's on that cache. So another way to do things is oblivious scheduling, where you have four processors, and each processor just have a bunch of tasks to run, completely oblivious of what the other processors are doing, of what the other cores are doing. This is very problematic actually because of bulk synchronization delays. Because unfortunately, the way that most programs are, you might have, for example, right now we know how that you have a parent process, you might have children, and these children might be waiting for the parent or the parent waiting for the child. The child can be significantly longer than the parent or vice versa. If you have such a system with multiple processes depending on each others, and all of them basically get scheduled at the same time on four different processors, that means that you actually have local you have local communication delays because you have bulk synchronization delays. Whichever runs the longest will affect your total time. And this is again a huge issue because it means that while you could theoretically run faster with a better scheduling, where you basically do not schedule the child that is dependent on the parent and that is dependent on the parent until the parent is done, for example. I mean, you can have all sorts of different that they still exist on different queues for different processors, but just do not schedule this task until this task is done. Okay, so these sorts of issues needs to be covered. Announcements. Assignment 2 was posted today. Um, it has a deadline that is actually 2 weeks from your first assignment deadline. We actually extended that too because we thought that if you have a deadline now, you're probably busy with your first assignment. Quite a few people needed a bit of extra time to do because they are unfamiliar with C and C++. So I hope that they had the time that they needed. So assignment 1 will be due on Friday, this Friday, basically in 3 days. Autograder for all the next assignments also work. I know that because there are over 100 students before you have used it, probably in the order of 300. So I'm not going to claim that I actually did not write it, so I can basically say, oh, it was not my fault. But I can tell you that if there are 300 previous students who used it and used it fine, well, it works. It's a very low probability that you will hit a bug basically that we have not covered, because this course is not just me. There is history behind it, right? You have to take care if there are spaces in your submissions. I mean, these kinds of issues can happen. Questions asked during the week and get late answers. I mean, I cannot possibly be 24/7 online. Neither are the is the TA, neither is Colin, neither are the UCAs. So if you want help, there are 5 working days every week. For us, I mean, we do work weekends, but we would definitely prefer to do work that is sort of uh, piling up on our backs rather than answer the questions. Not that the course is unimportant, but because we can answer you during the week, basically. Um, Again, when you send emails, please be a bit more specific. Things such as this does not run. I mean, okay, yes, I understand that your code does not run and that you have an issue with it, but give me more specific problems. Please come. I mean, I had one student coming for my office hours. You'll have Colin's office hours today. Tomorrow, Wednesday, basically. Uh, and that student had a very simple problem. It was a compiler problem. I mean, do exhaust all the other. Um, read first. I mean, I'm not saying that his problem is a trivial one. I'm just saying that um, when you compile your program and gives you an error, read the error. Do not just say that there is an error. Yes, there is definitely an error. Do not tell me that it does not compile and I do not know why it does not compile. It throws an error at you. Try searching for that error, and it's usually the very first line that you search for. You do not have to search because it's usually like multiple lines. Just search for the very first line, and things such as I've searched everything, I couldn't find the solution is like, yes, I mean, there's really not a lot that I can do uh, for these kinds of questions. I'm willing to help on compiler problem. I'm willing to help on any problems that you guys have on the assignment. Of course, I'm not going to give you solutions, but I'm willing to help with programming issues. What I'm just saying is that it's probably a better use of your time, because then you will have to wait until you basically get office hours with me, which might be like 3 days later or even a week later. If you have missed my office hours this week, then my next office hours are next week. And Colin, if you miss him tomorrow, well, Wednesday, then your next day is Wednesday, so another week. So you might have to wait for a week without being able to submit. A better use of your time is actually to try to do debugging. I mean, debugging is a very central thing in what we as computer scientists do. Uh, I'm not complaining about any questions that I get. I'm actually very happy with your questions. I'll take all of them. I'll try to answer them to the best of my knowledge. I'm just saying that, yeah, you might better use your time in a different way. Thank you, and I hope to see you on Thursday. And the next video lecture is also coming very soon.